Good morning and welcome to today's webcast brought to you by Oil and Gas Journal. I'm Paul Westervelt, Vice President and Group Publisher for Oil and Gas Journal. Today's event, A New Era in Oil and Gas, Critical Components of Bringing Subsurface Data to the Cloud, is sponsored by Amazon Web Services and INT. As the oil and gas industry works to take advantage of all of the benefits of moving to the cloud, it faces a host of specific challenges. In this webinar, AWS and INT will discuss some of the critical components that make moving subsurface data to the cloud more successful. Before we begin, just a few words about this webinar technology. This platform allows our audience to be more involved with the presentation and allows you to customize your webcast console to suit your own preferences. You can move windows around by dragging on the title bar or resize your windows by clicking on the lower right corner of any window and dragging it to the size you want. You'll notice a toolbar at the bottom of the console. These icons allow you to open and close the engagement tools on your screen. If you should experience difficulties with the audio or with the advancing of slides, simply press your F5 key to refresh your console. There's also a help engagement tool if you need additional assistance correcting your issue. This is a yellow icon with a question mark. We encourage you to ask questions at any time using the purple Q&A icon on the toolbar. We will address those questions after the presentation is completed. If we're unable to get to your question during the webcast, we will do our best to reach out to you afterwards. Today's presenters have made available a locked PDF of today's slides, as well as links to some helpful videos. These resources can be downloaded now or during the on-demand presentation by simply clicking on the green Event Resources icon in the engagement toolbar. Now I'd like to introduce today's moderator. Fabrice Buron is Chief Commercial Officer for INT. As INT's Chief Commercial Officer, Fabrice leads INT's sales and marketing efforts and directs the evolution of their data visualization offerings. A vocal champion of user-centered design, Fabrice earned his stripes navigating some of the top brands through the challenges and triumphs of digital transformation. You can learn more about Fabrice and each of our presenters in the presenter window on your viewing console. Now it gives me great pleasure to introduce Fabrice, who will begin today's presentation.
Thank you very much, Paul. Thank you for joining us today. Hello, everyone. I will do a quick introduction. You know, when we prepared this webcast and the topic of this webcast, obviously we thought about digital transformation. It's a very obviously popular topic these days in oil and gas. But we thought that what would be actually useful for the audience and what can they take away. And one of the things that really came to us, and I will use an analogy of what I really have as a passion, which is cooking, is what is the recipe and what are some of the key ingredients when you work into digital transformation, and specifically around providing access to subsurface data. It's something which is pretty hard to do. When we talk about subsurface data, we talk about seismic, GNG data, petrophysical data, and moving it to the cloud is not a trivial thing. So obviously, humbly, we want to share some experience here about some of the key components, ingredients, and how they come together. And for that, we've got two great speakers that are going to do that. They've been in the trenches working on this topic for a while. We've got today Sasha Saroglio of INT and also Dimitri Tichevkin from AWS. So this said, I will turn the floor over to you, Sasha.
Hey, thanks, Fabrice. So hello, everyone, and welcome. My name is Alexander, but a lot of people call me Sasha, so feel free. I'm a technical lead at INT, and in the last 4 or 5 years, I've been working on bringing digital transformation to the oil and gas. Today, together with Dimitri, we'll give a high-level overview of the key components, challenges, and solutions. So without wasting more time, let's dive in. Oil and gas industry is historically one of the first industries generating large amounts of actionable data. Here, for example, is the first seismic shot in 1932, and here is how the seismic looks in the modern-day IWAP. For more than 30 years, INT has been on a task of improving seismic visualization, and together with AWS today, we rose to the challenge of bringing exploration and production data to the cloud. Seismic data will be the focus for today's discussion because of the unique challenges which it's creating. Many of you already know that seismic is an image of subsurface, a look into the ground, if you will. And the data sets are monolith, often unstructured and massive. Some pre-stacked data may reach petabytes in size. It also doesn't help that the data sets are siloed in various data centers around the world, within a country, or even within a single company. This leads to data loss, unnecessary replication, and huge delays. In addition, it comes in many flavors, aka formats. Each flavor serves its own distinct purpose and is important to the industry. Some examples you can see on this slide. So naturally, a question arises as we see the technology progress. Can we leverage cloud to improve the data situation? And can we take advantage of the modern technologies? And where to even begin? So any digital transformation requires three key components. A strong infrastructure to provide the foundation for data storage, access, computations, and other fundamental operations. A standard and agreed upon methods and practices to data storage, access, manipulation. And finally, tools. Can't really make anything out of stored and accessible data if there are no tools to find, view, and analyze it. So first component is taking care of AWS. Amazon Web Services is renowned for their strong distributed cloud infrastructure. They provide reliable storage, compute, and over 150 other services to empower the cloud workflows. As per standards, OSDU is a new forum by the Open Group. OSDU establishes a standard for data storage, access, manipulations, not only within a single company, but across the entire industry. The architecture is independent of the infrastructure provider and applications as well, with implementations already existing for some major cloud providers. The goal of OSDU is to bring all the existing formats and standards under one umbrella, which then can be used by everyone, and the goal is to still support some legacy application and workflows until full transfer is available. Various applications can be built and integrated with such a platform implementation through some APIs. And one of such applications is IWAP, which is the third key component in our story. IWAP is a data visualization and analysis platform providing industry-leading tools for data discovery, visualization, and collaboration. IWAP also provides integration with various machine learning, artificial intelligence workflows, enabling some new ways of working with data arising from the cloud integration. Now, first, before we dive into solutions, we need to understand the problem. Oil and gas companies are truly global companies, and the data is often distributed among multiple disconnected systems in multiple locations. This not only makes it difficult to find and retrieve data when necessary, but also makes it difficult to even know where the data is available and how useful it is. I'm not even talking about things like usage metrics and other. So for an explorer to find such data often requires person-to-person communication, which introduces a major overhead. Some data may even be in the offline system or on somebody's desk. As one of my data manager friends said, you give someone a free lunch voucher and they hold on to it like it's their golden ticket, but you give them a drive with $20 million seismic data set and next week they don't know where they put it. The glue between all those systems are data managers, which are amazing at what they do, but they still introduce a human factor to the process. They have to understand which data set is being requested, then search for it on various systems, get access to it, and finally download and deliver it to the original requester. How much time this process takes? You guessed it, way too much time. Additionally, the requester often doesn't know how the data looks. They may get the name of the data set from a colleague or a subject matter expert, but never really see the data until it arrives on their desk. And after all this process, the explorer may still realize that the data they got doesn't work for them, and the whole process goes back to ground zero. Once data has arrived and interpretation and exploration took place, the following decisions are usually made based on static presentations with data screenshots from cherry-picked views presented to their peers. Sometimes this may lead to really bad decisions, which are very expensive. This limits the ability of specialists to make informed decisions, and this problem wouldn't exist if data was easily accessible in real time. So cloud brings solutions to many of these problems. But of course, moving to the cloud isn't a very simple task and poses a lot of challenges since day one of the process. In the remaining time, I would like to go over some of them and tell you how we approach those challenges. So modern cloud technologies are designed to solve exactly these kind of challenges. Using cloud storage like AWS S3, one can bring all the data within a single system where the data can be handled in a uniform manner. This enables data to be distributed and to reside close to the user, be moved when necessary or replicated, because all of the data centers are interconnected. And to visualize seismic in the cloud, as well as the other types of data, INT developed a native web visualization platform called IWAP. IWAP consists of a front-end client application as well as a backend. The backend takes care of accessing, reading, preparing, and doing all other manipulations with data for visualization. Manipulations is a bad word. Client application provides a set of widgets and UI components empowering search, visualization, collaboration of its users. The data reading and other low-level functions are abstracted from the client by a domain API and work through connector microservices on the backend. For example, to provide the support for a new data type, one only needs to create a new connector. Both parts provide SDKs for developers and some other perks as well. INT's work on bringing data into the cloud is mainly done in the context of IWAP. And okay, now that your data is in the cloud, a variety of services become available out of the box. For example, one of them is Elasticsearch, which helps index data, provides a search interface, and another service, which is very important, becomes available, which is AWS EC2. EC2 provides compute resources, which are distributed as much as the data is, and that's where IWAP gets installed. One of the cloud computing principles is that data has a lot of gravity, and all the computing parts tend to get closer to it. This means that it's better to place the processing power of computer as close to the data as possible. With AWS EC2, we at INT can place our backend very close to the data, regardless of where in the world the data actually is. This minimizes the latency for the user and enables on-demand access. Elastic compute resources also enable us to scale up when the usage increases and down when small amount of users are active. I want to stress the on-demand part here because when data needs to be presented, all the tools, technologies that I already mentioned come into play, enabling the users to pull up and visualize the necessary data in minutes or sometimes even seconds if you use IWAP dashboards and templates. And of course, the entire setup is secured on every level, from this data storage all the way to visualization on the client screen. As I mentioned earlier, INT AWS Cloud environment. In the AWS Cloud environment, INT installs IWAP and takes advantage of the EC2 compute services. So what we can do is we can deploy our backend to an instance in AWS Cloud and then connect the data sources and other services from the cloud using a set of specialized microservices or connectors. Thanks to the set connectors, it's also possible to connect to other data sources and services residing outside of the cloud, and all works at the same time. Then another perk is that EC2 provides auto-scaling and other cluster solutions like Kubernetes, for example. IWAP, being a web application, was designed to scale up and down as the demand requires, enabling to maximize cost efficiency of the running application. We can take advantage of auto-scale features and increase or decrease the number of instances as the demand requires. To continue a little bit on this auto-scaling topic, we make use of AWS Load Balancer, which aggregates all instances under one ingress point, one access point, if you will, and distributes requests coming from the client to the needed instance of the backend. It also provides useful tools like sticky sessions and SSL termination. And also, API Gateway helps us expose the backend to the web, enabling the client to access it from any location in the world. So, okay, once your data is in the cloud and everything is set up, next step is to make some use of this data, right? And to do so, we need to provide users a way to discover it first. What should be made searchable? How do we set up search? How to expose this search to the users? All of these questions come naturally with this process. Since searching through numerical values of the data doesn't always provide a lot of information, we need some additional data, which is called metadata, and this metadata comes along with it. And it's extracted whenever the data is extracted, the metadata also extracted with it. All of it, or a subset of this metadata, can then be indexed using Elasticsearch. And then IVAP provides an Elasticsearch connector, as well as tools to invoke the search through an interactive map interface. It gives things like filter forms, search by map, search by area, and other perks. And the whole left side of this slide is described in OSDU architecture, and it has already been implemented as per today. And now to the tasty part, to the visualization. There are two very different approaches to visualize data. One is to do it on the server and then send rendered images to the client. And the other one is to send data to the client and visualize it on the user's machine. The last method provides limitless interactivity and responsiveness of the visuals. It's sky is the limit here, really. IVAP implements both of these types. However, the latter approach poses a special challenge similar to what we've seen earlier. Data is just too big. How would one transfer terabytes of data from server to client using to the client somewhere in somebody's home office and not have any latency problems, right? Network is a clear bottleneck here. But first, it's important to understand that not all data is always visible on the screen. We can calculate which parts of the data we need to present, which part is visible, and this we can do it in real time at any given moment. And some of the newer data formats are designed to operate in this way already, but here we're talking about legacy a little bit. So to properly calculate and read the location of the desired chunk, we need to first have a map. It's called an index, and it's used to calculate the offset and the size of the chunks which we need to read. And once we identify the chunks, even then the data might still be too large to transfer over the network. Luckily, don't get too sad yet. We don't have to transfer all the data just yet. If a user's screen has 3,000 pixels, they won't be able to display all 6,000 traces. So we can adaptively decrease the number of traces to provide for optimal performance. And not done yet, even more. Often the chunks which are read in multiple different places in the file, wait, let me roll back a little bit. Chunks are often located in different places in the file, making it necessary to do multiple reads at the same time. Luckily, both S3 and IVAP support such behavior. We can fire off thousands of requests in parallel, maximizing the efficiency of over the network. As some people like to say, living it to the full. And even then, there is one more step. Once the traces are picked and ready to ship, we do some vectorized compression before shipping the data off to the client. We were talking about legacy file formats here, but it's worth mentioning that GPU compression and some compressed formats out of the box like VDS also exist. So then all the preparations have been done, data is sent to the client, and different technologies, JavaScript, WebAssembly technologies come together to decompress the data which has just been received. With the same technologies, through some beautiful widgets, the data is then presented to the user, providing a lot of interactivity and control. Sometimes building a dashboard with live data and data from the cloud can take literally minutes. It is worth mentioning that as more and more workflows move into the cloud, new seismic formats emerge addressing the new challenges. They support compression within the file storage, compression inside different levels of details, random access patterns. All of these formats become more and more exciting, especially with the new workflows which arise with the cloud. And finally, let's just say Explorer Mary sitting in Houston, Texas. She can create a dashboard, save it, and the templates as well, and then she can share them with her colleague, let's say Akil somewhere in Kuala Lumpur, who will be able to pull it up in the middle of his presentation and show informative dashboards with live data. Given time difference, I hope Mary gets paid overtime. So far, we went over some key components. I talked to you about the two main components. We discussed the standards, we discussed the visualization, and now it's time to talk a little bit about the infrastructure, which is the foundation of everything. So Dmitry, are you ready to take over and tell us some more about the AWS side of things?
I am surely ready. Thank you,
Okay.
Sasha, and I'm glad to have you here, and INT is our great partner. So to start with, AWS. At AWS, we expect that energy system of the future will be vastly different from what we know and use today. Business needs to better manage what they have today while simultaneously building for a different tomorrow. And AWS is committed and dedicated to support oil and gas industry by helping our energy customers to transform and innovate across their complete energy value chain in upstream, midstream, and downstream. Our team brings decades of expertise to energy customers. So let's look how to bring your subsurface data to the cloud. Let me ask a few questions. How many of you know how much subsurface data do you have? And there's a rhetorical question, just don't need to answer. And how much of that data is a duplicate? Yeah, these are tough questions. Our use case for seismic acquisition and storage is focused on streamlining exploration workflows while reducing development risks. And we'll look at these three main areas on the screen. And INT IWAP plays a key role to enable search, discovery, and in-place visualization of subsurface data by reading, preparing, and aggregating migrated and acquired data. It helps you manage your data at scale. Quick decision-making comes from removing inefficiencies in the data workflows. In traditional and siloed systems, it's very hard to find data because it's spread across several applications, databases, even tape backups, and data is locked in those proprietary systems that can be accessed only using the vendor application. So you want to liberate your data. Solution to this problem comes from opening up the data and bringing it all together. Many of my energy customers refer to the acquisition, to the processing workflow cycle time as a time to first oil. This currently averages from 18 to 36 months. And I believe by eliminating inefficiencies in the data transit time, you can get it from half to 1 month time. Another opportunity here is IT infrastructure cost reduction. These reductions come from economies of scale. AWS has millions of customers using storage and archive, and will allow you to trade the capital expense for low variable operating expense and only pay for IT services as you consume them. So here at Woodside, we want to improve management of thousands of tapes of data at scale, and with another multi-petabyte of data coming in just 2019 alone. Woodside teams had a problem of getting data out of the tape. It was very time-consuming, taking 6 to 8 weeks. Off-site storage tape facilities charge high extraction fees, and in case if you need them fast, rush fees as well for faster extraction and shipping. And these fees could reach thousands of dollars. Also, tape itself carries some invisible costs. So tape is never full. It's about 70 to 80% that you can fill it up. because of subsurface data formats like SegY, SegD. And second, tapes have to be duplicated every 3 to 5 years. That also costs money because tape degrades over time with risk to completely lose data. So our team worked backwards from the Woodside vision of removing those inefficiencies, and cloud was the solution to the problem. We helped Woodside to move subsurface data to Amazon Object Storage called S3, and going to the cloud was not expensive. So if you look at the top graph, it shows it was a cost neutral to keep all your data hot, as we call, so with immediate access. But performance and efficiency to access this data was 10 times faster. Also, cloud storage never degrades, and your data is duplicated at least 3 times across different availability zones. Combining all this data together allowed Woodside to put it all into technology that powers search, and geoscientists can search what and when they need in a complete self-search catalog of available data with a map view. So this work opened up a new avenue for further innovation and discovery of new use cases like machine learning that adding value to the seismic workflows. I included a link to white paper for you to read more. This white paper written by Jess Osman from Woodside. Feel free to download it and read in more details. So what are the critical ingredients in the cloud to bring your data in? This diagram I developed based on my multiple customer engagements, so follow me through the journey. First of all, you need that scalable, robust storage infrastructure, and most customers in the cloud use Amazon S3 as their storage solution because it has the most functionality and unmatched availability, durability, and scalability, and it's most secure data store. Then you need acquired data delivery, so a bot or a truck that stores data locally over a few weeks of acquisition obviously leads to a long time waiting and error prone during data transfer times. It could be months before you see your first trace of data. You can replace that with one managed and reliable data transfer service, and at the same time you can enable real-time data delivery of a critical subset of data via speculate, applying compression as it goes. So this enables real-time data delivery for the processing, visualization, and interpretation (NQC) of your seismic. Next is your tape offline storage. Data from tape, it needs to be transcribed, copied, and delivered to the cloud. Could be done in a matter of weeks, and it's only limited by tape's facility resources and the throughput. And the next is your data center, where you obviously keep some subset of data as well. And this data could be moved online, and we offer a wide variety of synchronization services that I will talk soon about. So these services are designed to be simple and move your data fast in large amounts and be very efficient and cost-effective between on-premises and cloud. So moving on to number 5, once you have your data in the cloud, it's time to extract some value of it, right? Here's where IWAP fits in this workflow, and it will visualize the data, manage your data at scale. And I brought in another example of HPC, seismic processing, where you bring compute close to your data. And so you can bring your HPC infrastructure to the cloud as well. So, and going to the last piece is a seismic archive or cold storage, as we call it. We offer cost-efficient storage that's called S3 Glacier and S3 Glacier Deep Archive. And also you can migrate your seismic interpretation workflows and applications. We offer a latest selection of NVIDIA GPU and Intel CPU with reliable and secure cloud streaming right to your desktop. That streaming is powered by a nice TCP streaming protocol, or you can bring your own streaming protocol if you want to. For your information, I included all AWS storage options in the cloud. You can schedule automated data transition from S3 to most cost-effective storage tiers automatically by doing it only once. And then it keeps working across all of your data, saving you money. So, how do you bring your data to the cloud and maybe keep some of it on premises? Maybe sometimes cloud is a journey, and most of the time your organization will have a roadmap and milestones how to move to the cloud. Often I hear questions, how can I move to the cloud and keep my workflow or part of it on premises? For example, let's look at the business problem when you need to move one of your assets in particular geo, say, for example, Gulf of Mexico to the cloud. And your organization will need to share this information with other global asset teams, but due to constraints, need to maintain seismic interpretation workflow in the office. AWS data synchronization and hybrid services are the solution to this problem. You start today by moving your data gradually to the cloud, directly into cost-efficient storage or hot storage. And this move will not impact your existing workflow. Transfer is secure and encrypted. And once in the cloud, your team still operates as what they do. And other team around the world can immediately see results of their work. They can collaborate during reviews, meetings with live dashboards. And you seamlessly also enable remote work during this COVID times, as data now is accessible from anywhere. With all of that, you still retain most hot data in the office, which is powered by AWS Storage Gateway on the bottom. This solution lets you gradually reduce the data center footprint, and hybrid cloud makes your migration journey smooth and reduces friction to the business processes. All right. So sometimes you have a lot of data, and in case of seismic, it could be several petabytes or even tens of petabytes. And at the same time, internet bandwidth is constrained. So it could take months or more than 4 months, for example, for 1 petabyte volume to be transferred over 1 gigabit of channel internet. So for that offline data transfer, we created a Snow family of transfer products. They come in different sizes, small, medium, and large. And these devices are secure. Information is automatically and transparently encrypted. Smallest one can fit into a standard backpack, taken to the field or any remote office. Medium device weighs about 50 pounds, provides plenty of storage and even compute to run as an edge device. These devices can be clustered together to scale up when you need it, and when you don't need it, you can just shut it down, disconnect, and send it back to us. Devices are capable of offline running as long as necessary. So these devices are also ruggedized and protected by strong outer shell with military-grade materials. And I want to show you a little video. Okay, so with all the new technology, oil and gas industry still relies on some traditional data transfer between parties such as vendors, operators, joint ventures, data exchange, information submission to standard bodies, and many other use cases requiring data sharing. This is often powered by Secure File Transfer Protocol, or SFTP. And did you ever have to purchase hardware for SFTP or procure new vendor in your SFTP workflow? These processes obviously take a lot of time and do not add value to your business. With AWS, you can easily and seamlessly modernize those. The transfer family lets you preserve your existing data exchange processes while taking advantage of the economics, data durability, and security of Amazon S3. With just a few clicks, you can set up SFTP protocol endpoint, configure how to store, transfer data, set up your end user authentication by importing your existing user credentials, or you can integrate existing user provider like Microsoft Active Directory or LDAP. Your customers, partners, vendors can continue transfer files using existing clients. Nothing will change on their side. While files are stored directly in AWS S3, you will no longer have to purchase and run that SFTP servers and storage to securely exchange data. So AWS manages your file infrastructure for you, and it includes auto-scaling, capacity, and storage, and maintaining high availability and redundancy built in. Another use case you most likely use in one of the storage partners presented here. Most popular are NetApp, SoftNet, Cubalone. We created AWS Marketplace just for that. It's a digital catalog with thousands of listings from software vendors that make it easy to find and test, buy, and deploy software that you can run. And so you can seamlessly migrate what you have in-house right now to the cloud. So you can provision your favorite storage in minutes, and any storage will be just a click away. You don't need to procure and install hardware for it. And if you need more storage, with just a few clicks, you can add it. All the billing will be consolidated into one single bill with line items on it. And if you don't need that storage anymore, you can just turn it off and don't pay for it. So what's next? Well, once your data is in the cloud, you can start thinking of new workflows. Machine learning assisted interpretation is one of them, but there are many other seismic interpretation workflows, such as fastious classification, quantitative interpretation, geobody interpretation, microseismic event horizon, velocity peaking, image analysis, and machine learning can certainly improve and add value on top of those. For the well log processing pipeline with aggregation, cleaning, enrichment, formation prediction, and offset well correlation workflows, your domain experts will spend less time doing boring and repetitive work and more time adding value to the interpreted seismic volume or well logs. Every time you start machine learning project, it should start with a well-defined business problem and agreed on a success criteria and KPIs. At AWS, we offer a variety of machine learning services, from building blocks like machine learning workstations to ready-to-consume services like Alexa, and transcribe services from voice to text and text to voice and others. We also have a SageMaker service that sits right in the middle of this lineup. It is fully managed service that provides every developer and a data scientist a collaborative workflow to build, train, and deploy machine learning models quickly. It removes heavy lifting from each step of this process. Traditional ML development and integration is complex and expensive process, and you need to stitch together those tools. Have you ever tried to integrate what your data science team have done with a commercial application? Yeah, that usually takes time. And SageMaker solves exactly this problem. It automatically integrates developer and data science work. You can build your own models, or you can, same way as a storage, you can buy ready trained ML models from the marketplace we created, or you can even sell them there if you develop your own. So INT has built an integration with AWS ML services. It complements SageMaker by providing real-time visual display of your data, showing you results, training, and running on the ML model. And let's recap what we talked about. So you can start planning and moving workflow of your choice today to the cloud. You can pick most time-consuming process or process of your choice, develop a POC and scope. You can start small today and expand tomorrow by seeing as success. Repeat on your past project experiences and learnings, and define KPIs. Take one of your past projects and measure what it took to do it traditional ways, and define those KPIs and do it again in a cloud. And keep momentum going. Migrate more of those workflows after first success, so capitalize on it. And then after time, you will see your data build up. Try machine learning at that point, and build the foundation for a different tomorrow. And that's all I have today. Thank you for your time. Pass it back to Fabrice and Q&A.
Thank you very much, Dimitri. We're going to skip to Q&A. Thank you, Sasha. Thank you, Dimitri. So we got a lot of questions that have been coming up through the presentation. So please feel free to ask your question through the Q&A chat box. The first question that we wanted to ask, so we've got some questions that are more infrastructure, some that are more applications. So I'll take them in the order kind of they came through. The first one is, how do you handle the latency for moving the data? So Sasha or Dimitri, do you want to take this one?
Yeah, so I assume this is moving data from an on-premise solution to the cloud. Dimitri, do you want to answer that? I think you have a slide on that.
Fabrice, can you please repeat question?
How do you handle the latency for moving the data?
Sorry, I could not hear you. How
do you handle the latency for moving the data? Can you hear me okay?
Yes. How you handle latency of moving data to the cloud, right? Sorry?
Right.
Okay.
Yes, I assume so.
Yeah, okay. Well, so you can have, as I said, several ways of moving data to the cloud. And the latency really depends on how you define it and what your requirements are. For some workflow, a latency of several seconds, it will be unnoticed. Some workflow will require maybe real-time latency of a few seconds. That could be addressed with other solutions that I didn't mention, like you can have AWS Outpost if latency is very, very critical, and AWS Outpost is installed in your data center. Other latency type need to be looked at based on the business case and use case.
Thank you, Dimitri. I think it's a broad question. And Sasha, maybe do you want to discuss maybe on visualization? I mean, since we're not moving the data we're accessing and streaming, so maybe you have a comment on that.
Yeah.
On how you
yes. So one of the benefits of having data in the cloud is that you don't have to bring and download the data back on-premise in order to visualize or work with it. You can work with it directly from the cloud. And then that latency, I think I described it in some of the slides. We do a lot of data pre-processing before moving it to the client to visualize. So that's where we try to minimize it. Of course, there is network bandwidth and latency, but that's a given.
Okay, very good. Thank you very much, Sasha. Another question that we have is what compression technology is used?
So I see it's for compression. So compression technology is the one that we developed in-house. It actually takes advantage of multiple compression algorithms, and I don't think I can disclose all of it, but the takeaway is that we have a lossy compression, which couple of compression algorithms come together, and we can control the compression. So we can it gives us a good trade-off between the compression level and between the error that you're getting, basically. But yeah.
Okay, thank you very much, Sasha. The next one is, can you briefly touch upon ways to integrate with interpretation platforms such as Petrel, Decision Space, Emerson?
Yes, so there are, I guess, two parts to this. One is a long-term vision, and the long-term vision is that all of those platforms will eventually learn to work with the cloud the same way as IBOB works. But I know some teams are already working on this kind of solutions for these major platforms. But in the short term, there is a little bit of a hack, I guess, of a short-term solution that gets implemented by various companies. I think some of it is described in OSDU. It's where, when necessary to work with these legacy platforms, data gets replicated to where the application is installed. But I don't know too much about this topic, though.
Mm-hmm. There's one thing I want to add a little bit. Yeah. Sorry, go ahead, Dimitri.
I can add a little bit, yeah. So all these applications are already available on AWS. They're running on AWS Cloud, and you can check out the references. How you integrate, so we are OSDU, there is a special workflow defined where you check out data and it moves to the storage that these applications understand, be it a local disk storage or a shared drive. But these workflows have been defined in OSDU already, and I believe it will be available with OSDU R3 release. If you're outside of OSDU, you can define your own automated scripts to move data, and we offer all the services for this. For example, a data sync service could be used just for that. It will synchronize between Amazon S3 and another Amazon service that I have not mentioned. It's called Amazon FSx for Windows. It's a special SMB file system without serverless file system. You just create the file system and put files on it, and using Petrel and other systems.
Yeah, thank you, Dimitri. Yes, one of the things also I wanted to build on both of you, what you said is really OSDU is a standard that's going to drive all these different platforms to make their format also compatible and bring interoperability between the platforms. So how do you integrate is being able to read that standard and in that case use that data regardless of the application. And I think that's where the whole industry is leaning towards, to facilitate that integration versus having just I would say a one-off every time you have to connect to the system and read the proprietary format. All right, very good.
Exactly.
Next question is, about are you using CPU or GPU for reservoir management?
For management,
Yeah.
I guess the question is about the visualization. And when we visualize on the client, we are using WebGL, which works which renders on GPU. So GPU is the rendering horse.
Okay.
That's it. Yeah.
So there's another question, the next question, and we've got a lot of questions. I'm going to try to address them, all of them, but if we don't, if we're not able for any reason because of lack of time, we will follow up individually with your question. So we're a new company, just start from scratch, and we're planning to set up, we're planning top setup, conventional through a local storage device in our small office. So the question is, I'm sorry, this one is actually not clear. So we'll follow up with you and maybe ask clarification. Okay, by comparing the FTP or SFTP, what's the pros and cons? In other words, does the SFTP worth? Do you want me to repeat the question because it came in two questions actually?
Yes, please.
Okay, so they're setting up actually their local storage device in a small office, and what they would like to know is the pros and cons using FTP versus SFTP. What are the different pros and cons of that?
Okay, I can briefly touch. SFTP is encrypted in transit. That's a main feature of it. So your data might, if we're using FTP, data might be intercepted during the transit. SFTP encrypts the data in transit. That's the biggest difference. Plus, it's a newer protocol.
So the next question that we have, so just wanted to ask, how is the reaction of oil and gas operator and service companies towards digital transformation in cloud, especially mid and big scale companies with the fluctuation and instability of oil market? I think that's a great question, and if you don't mind, I'll take it, Sasha and Dimitri. I think the common answer we're seeing from all the majors and services company we're discussing with is I think it's a necessity to move into the digital age and accelerate through automation. There's huge pressure of cost reduction, and as you can see, the companies understand that. It was not a matter of if, but it's just a matter of when. And I think the pandemic and the market situation has really accelerated that transition because people need access remotely to their data. You need to decentralize the decisions. So you need that data. When we're talking about field exploration, we're talking about decisions that cost millions of dollars. And you need an informed decision with all that data. So, in the past 10, 15 years, the traditional situation was when everything was good in oil and gas, well, everybody was too busy to probably focus on the technology and the transition to digital. And when the things were hard, it was a cost reduction. And I think what's changed this time is that we don't have this two situation. We have the imperative to transition, as a whole industry. And out of that, there's been a lot of fantastic opportunity to embrace, to leapfrog and embrace, the latest technology and innovation. Whether it's, machine learning for automation, the cloud storage, which was something that was very taboo 2-3 years ago. How do you ensure security? How do you ensure, cost efficiency and all that? So I think that's a very good question, and I think the industry is ready for that. We've got a couple of minutes, so we're going to do another couple questions here. So I don't know if you've got the answer necessarily, Dimitri, but regarding the Wood case study, how did they implement the transcription of PB's of data from tape in a cost-effective manner? a lot of E&P companies balk at these significant upfront costs. So do you have any insight on the case study specifically, Dimitri, in terms of cost effectiveness?
The question is specific on transcribing tape data to the cloud.
Yeah, transcription of petabytes of data from tape.
I don't have the details, but I know it was done with a tape partner, or several partners were involved who manage tapes. Plus, there was a system integrator involved to help and manage all of this project at scale. I could certainly dig more into this and provide it. I will also would suggest to read the paper. It might open up more details in this, that it's in the webinar resources.
Okay. And the last question that I have is about, actually, we talk about security. Is it really secure to have such sensitive data in the cloud?
I can take on this. Yeah, definitely. Security is our top priority. So AWS have been built to be flexible and secure computing environment, and our infrastructure is built to satisfy security requirement for military, global banks, and other highly sensitive organizations. So we're using same secure hardware and software to build and operate in each of our regions. And we've been working on this for more than 20 years now. So this is also backed by a set of our cloud security tools with more than 200 security, compliance, and governance services and the key features. We also have a long range of compliance and other standards that could be checked out at our AWS compliance page. Feel free to check it out.
All right.
And to talk about IWAP side a little bit as well, we also have accessing the data, so we also provide security and specifically identification, authorization of the user. So on every step, between every communication, between every service, the identity of the person accessing is being checked to ensure maximum security.
Thank you, Sasha. So we're on top of the hours. There's a lot of other questions. So we've got about a strong handful of questions. So we will follow up individually with you. You know, we've got who submitted it, so we'll do that. I apologize if we lack a lot of time, but obviously it's a topic of interest. So Paul, I will hand it over to you to close maybe the event.
Thank you so much, Fabrice, and thank you to our presenters as well for an exceptionally timely presentation. Today's presenters have made available a locked PDF of the slides, as well as a couple of additional resources that you may want to download before you leave today. There are links to some helpful videos, as well as the white paper that Dimitri mentioned during his presentation. These resources can be downloaded by simply clicking on the green Event Resources icon in the engagement toolbar. Before we sign off, I would like to thank our presenters today. Sasha Sarioglu is Software Development Team Lead for INT, and Dimitri Tiskatin is Principal Partner Technical Lead for Energy for Amazon Web Services, as well as our moderator who did a terrific job today, Fabrice Buron, who's Chief Commercial Officer for INT. I'd also like to thank our sponsors, AWS Energy and INT, and to remind you that an on-demand version of this webcast will be available on the OGJ.com website within 24 hours of this live presentation. The link will be to the archived version will be sent to everyone who registered for today's event via email as soon as it's available. Please feel free to forward that to colleagues or others in the industry who might find this presentation of interest. On behalf of AWS, INT, and Oil and Gas Journal, I'd like to thank you for attending. Have a wonderful day.